folks kind of startle a guy when you sneak up on him like that. Welcome back to my shop. I'm Charlie Nelson, and we're just finishing work up on our Waco scale model aircraft. You've come at a very opportune time because I've been working on this airplane for a year and a half now, and I've just got it to the point where we can fly it. And with a little bit of luck, tomorrow afternoon on Saturday, myself and a few friends are going to go down to our local flying field and try flying this airplane. But before we do that, perhaps I should put the cowl and the propeller on so that I can show you how the airplane will look when it's finished. Before I put on my cowling, which is handmade, this is made out of fiberglass. It's made in a mold that I generated by hand here in my shop, and it weighs close to ½ pound. It covers up this working 7-cylinder Seidel, that's a brand name, radio engine. This engine is made in Germany, and it has 4.2 cubic inches, and it makes 4 horsepower at 6,000 RPM. And it swings a 22-inch propeller, which for most of you can relate to your lawnmower, because most of you have a power lawnmower that's about 22-inch cut. So this propeller is as big as the blade on your lawnmower, and this engine is as powerful. The airplane right at the moment weighs 28.5 pounds, and I've been working on it for a year and a half, somewhere between 1,500 and 1,600 hours worth of time. And as I said, the airplane is not complete, but the airplane is airworthy, and that means that the airplane can be flown, safely flown, but all of the details are not manufactured, such as surface details on the wings. There are inspection covers and air scoops and hatches and all sorts of things. I still have another couple hundred hours of work to do to make this airplane complete to the point where I can compete with it in competitions. And depending on what happens tomorrow, because it all could be lost in a split second, but I really don't think it will be, we'll be down in Florida with it in the spring, provided I get invited to the Top Gun tournament again. That was just my son outside the door there. Okay, there's the propeller on. There's our 22-inch propeller in front of the cowl. And this propeller can absorb the 4 horsepower that this particular engine generates. And hopefully this engine will have enough power to raise our 28-pound airplane into the air. The engine runs on a mixture of alcohol and nitromethane and uses synthetic oil just about like a chainsaw in mixture. The airframe is built out of balsa wood and plywood. It features some parts that are made out of spruce, such as the fairings on the wires. We have end strut fairings that are made out of spruce, and diagonal braces. You probably can't see those too good now, but we'll put the wings on the other side. And it is flown by radio control. If you'll just give me a moment here to walk over and pick up my transmitter. This is a radio transmitter, and by turning the transmitter on and turning on a receiver, much the way you would turn on your television set, we can bring our airplane to life. On the back of the airplane you can see the rudder wiggling from left to right. You can see the elevator going up and down. The elevator controls the pitch of the aircraft, the up and down. The rudder and the ailerons are on the wings, control the roll axis of the aircraft, that is its ability to stay right side up or upside down. We can control many functions on this aircraft. We have aileron control, we have elevator control, rudder control, engine throttle control, and engine mixture control. We have retractable landing lights. Yeah, we got one down on the far side. The lights aren't in place yet, but the frames are there and working. And we also have landing flaps. which are one on the other side, which you probably can't see. But you can hear it go, I'm fairly certain. And perhaps I should take a moment right now to illustrate to you exactly what the radio control components are. First of all, we have a transmitter. This is a radio control transmitter. We turn the power on, which turns on the pretty blinking lights on this particular model. The blinking lights indicate certain functions are operational. This stick controls our elevator. It is proportional. We move the stick a little bit, our servo moves a little bit. We move the stick a lot, the servo moves a lot. Elevator, aileron, rudder, engine throttle. And on this particular one, landing flaps, 3 positions, down, halfway up, and fully retracted. Now the transmitter sends a signal out its antenna, which I'll leave pushed in because my shop room is quite small here. And it sends out a signal which is received by a receiver. Now this is a receiver, just the way your radio in your car is a receiver or your television is a receiver. This one is an 8-channel receiver. It can control 8 different functions. Now the next most important component is a servo. Now this is a mini servo as opposed to a micro servo or a giant servo. This is what actually does the work. This little black box has an electric motor in it. It has a transistorized electronics board in it that controls the servo, and the motor runs a gear train that moves the servo arm, and the servo arm is what actually does the work in the airplane. Now if I plug the receiver, the servo into the receiver, and we'll use a battery. Here's a battery pack. This is pen cells like you put in your flash gun. AA cells, but they're nickel cadmium cells. They're rechargeable batteries. If we plug this into the receiver, and then we can plug, let's put a couple of servos in. We'll plug one in here on channel 4. We'll plug one in here on channel 3. And we'll lay these over on their side so that, okay. As I'm working the elevator control, you can see that nothing is touching that unit. It's working by radio control. I'm working the servo that's connected to the elevator channel. And if we do it like this, you should be able to see it. You can see that as I move the stick a little bit, the servo moves just a little bit. It follows exactly what I tell it to do. And we have rudder over here on this servo, and you can see that as I push this stick just a little bit, the servo follows. Almost as fast as I can push the stick, or 1/1000th of an inch at a time. And that's how radio control works. A servo would be connected through a push rod to a control surface on our model airplane. And that would be, this is what actually supplies the mechanical effort to move the control surface on the aircraft while the aircraft is in flight. Okay, now that you understand a little bit more about radio control, perhaps I'll talk to you a little bit about radio control scale modeling. That's what I am. I'm a radio control scale modeler. And just exactly what does that mean? That means that I go to an airport and find an airplane that cranks my starter, and I take my camera and I photograph the airplane, take as many as 100 pictures of it, and I come home and I draw a plan to scale so that my model will look like the real airplane, and then I go ahead and build it. A year and a half ago, I started work on this aircraft. Its scale is 2.8 inches equals a foot. Now, for those of you that doesn't mean anything to, 3 inches to the foot means that's 1/4 of full size. This airplane is just a little bit smaller than 1/4 of the full-sized airplane. Its wingspan is 93 inches on the top wing. That's 3 inches short of 8 feet. The propeller is 22 inches. It weighs 27 pounds. It's taken me a year and a half to get it this far, and if we open our documentation book over here, hopefully you'll be able to get this without too much glare on it. This is a photograph of the full-size airplane. Picture was taken out in Ohio in 1991. That's my friend Don standing in front of it there, so you can have an idea of how big the airplane is. And the model behind me here is a scale replica of the full-size airplane as it appeared in 1991. And this airplane will be used in competition, hopefully in the next several years, by myself. That's what being a scale modeler is. Now, most people think of a scale as something you step on in the morning and look at the numbers and you shake your head and say, I got to start dieting today, but today never seems to come to visit us. Why don't I put the wings on this side, and now we'll add another dimension to the airplane. This is the lower wing. This is the diagonal brace. This is an aileron drive bar, and you're probably wondering why the ailerons aren't painted pretty red like the rest of the airplane. And that's very simple. It's because I haven't gotten around to making the mold to make the simulated corrugated aluminum aileron coverings. That's another project that I have to work on this winter. I'm going to have to be impolite and turn my back on you here for just a moment while we plug this wing panel in. First we plug in the wire that runs the servo. The servo, I just showed you how it works. There's one in the wing panel to make the ailerons go. We close the latch on the wing, connect the diagonal brace, and the bottom wing panel is in place. Now we have a top wing panel. I'm going to have to be impolite once again. And we plug the servo in. The servo works the flaps. Plug the servo in, work the latch, and we have a rubber band here that we take off, and that drops the struts in place. And the struts are fastened in place with Allen head number 4 screws through fittings just like there would be in full size. And we put these down in the slot, and nothing ever works when it's supposed to. Murphy's Law. And there's a front and there's a rear. I'm not going to hook the rear because I don't need to. And we have an aileron drive bar that comes around here and attaches with a single screw onto the aileron. And now we can bring the airplane to life again. Over here, this other radio, this radio sells for $1,200. This is a very fancy, sophisticated, computerized radio. Now we have ailerons. You see the ailerons all right, folks? They're out here on the wingtips. Down and up. Okay. We'll have landing lights. It'll look like a toilet seat comes out of the wing right here. These are the frames for the landing lights. I don't have the lights in there yet. Another project, up, down. The landing lights will swing down out of the wing and illuminate. And at the same time, there's an anti-collision beacon, a red blinking beacon. It'll be on the top of the fuselage that will be illuminated. And these little things out here, these are the wires. There's red and green lights on the wingtips, and there's a white wire up on the top of the vertical stabilizer that are not manufactured yet. And the next thing is the landing flaps, which aren't painted because their metal covering isn't on them. Half flap and full flap. Landing lights are down, lights are up, flaps are retracting. All of our functions work fine. We can close and latch the door, in itself another story. And that's basically where we are, and this is the way the airplane is going to look tomorrow when we fly it. And just for comparison, it may be pretty well blocked out from your camera, but in the background there's my current model that I'm flying. It's 2.25 inches to the foot, and it appears quite small in comparison to my new airplane. Well, I hope you've enjoyed your visit here tonight. I've got to get back to work. Oh, here's another thing of interest right here in front of me. Let me turn this off. And when the airplane is done, it will have a fully upholstered interior. No doubt many of you have seen doll houses with furniture and bureaus and rugs on the floor and sinks and toilets. Well, I have to build seats and things. And here is the start of my instrument panel. The way most people have make doll houses with rugs and bureaus and little toilets and kitchen sinks and refrigerators. This is my instrument panel, and the instrument panel is the dashboard of the airplane in automotive terms. It has our instruments on it that indicate where we are in the sky and how our engine is running and how high we are and what direction we're traveling. And its basis is a piece of 1/16 inch diameter thick plywood. And then we have a second section behind it, and this is a piece of cardboard and some clear plastic. And the instruments are copies of full-size aircraft instruments, and I'm quite thankful to the help of an enlarging copier, because that makes making some of these things really easy. You can take a small one and pop it up to a larger size on the copier. And this is as far as I've gotten with the instrument panel. The pieces slide together like this, and then they're screwed into the airplane with the various handles. I have to manufacture the seats and upholster the seats. The inside of this airplane is upholstered in leather. The only thing I can simulate leather with is vinyl. So I have to go to a fabric shop somewhere and find the right color of vinyl and strip all the fuzz off the back of it and use it to upholster the inside of my cabin and my seats. So like I say, I still have a couple hundred hours to go, and if we make it through tomorrow, folks, we should be on the road to success. Thanks for stopping by.